Hey guys, and welcome to Functional Print Friday. Welcome back to my shop. I want to do something a little bit different this week. A while back on the channel, we made this, and this is a speed handle for the vise on my milling machine. I'll just show you quick. So there's a hex here on the vise, and this just slips over onto that hex and then allows you to turn this very quickly. So if you want to make large adjustments, say we were all the way out here and now we're putting a small piece of stock in, it's way faster to turn it this way than it is to turn it with a wrench. Now you do still need to turn it with a wrench once you get close because you can't get as much torque with this as you can with a wrench, but for making large adjustments in the vise, it works really well. And when I made this, I remember saying that, while it would be nice to have the whole thing in aluminum, I actually think that this is a great use of 3D printing because there's a fairly complex geometry to this. I mean, we could probably simplify it some, but having sort of one diameter at this end, one diameter at this end, this section raised, and a hex in here, some bevels on that. We could manually machine that, but it would be quite a bit of work. I think we could probably do the radius on the rotary table. Same thing for this side. We could probably do the hex on the rotary table as well if we fixtured this on there so that we were cutting each part of this hex as a straight path with the table moving back and forth, and we just rotate that around. Like, it could definitely be done, but it would be quite a bit of work. And it wouldn't really get that much faster, making additional ones. Now, I'm not interested in making these and selling these, but I have always thought it'd be neat to have this part in aluminum. So if you've been with the channel for a little bit, you will probably remember about 2 months ago when Makera reached out and offered to send a Carvera Air out to the channel for use in some projects. And I actually did not mention them by name, but I made it pretty easy to figure out who I was talking about because at the time these machines were on just about everybody's channel. I mean, you'd have to be under a rock to have not seen a video on the Carvera Air at this point. But it wasn't going to happen on this channel because the requirements that they were asking for, and I say they, I don't know that I was really talking to Makera. When you get an email as a YouTuber from a company offering to send something, you never know if it's really from the company or a marketing agency that they have contracted to work with. And many of these companies work with multiple marketing companies. But whoever I was talking to had some pretty unreasonable requirements for editorial control, publishing schedule, and a number of other things on this machine. And it was just a hard no from me. Now, I have discussed this a couple times with my patrons over on Discord, so this video is probably not going to be a surprise to anyone that is a patron of the channel. But what everyone else watching this video does not know is Makera has actually reached out 2 more times. The second time, I just ignored them because I didn't really want to waste any more time on going back and forth. The third time, I did notice it was from a separate email address, and I just sent them a link to my review policy and said, I'm interested if you will agree to my review policy. And it did take a couple days, but they wrote back and said, sure, let's go. And in case you're wondering what review policy I'm talking about, it's this one here on my site, and I will put a direct link to this review policy down in the description of the video. But in short, I don't allow any editorial control over my videos. I don't like companies dictate what to make the video about, what to say in the video, what not to say in the video. They don't approve the video. They don't get to see the video before I publish it. I send it to them at the same time I hit the publish button and you guys see it in your feeds. I also don't accept any payment from companies to make these videos. And the whole point of that review policy is to avoid bias as much as possible. But to be fair, I do want to point out Makera did send this machine out to the channel completely free of charge. Now, when I said this video is going to be a little bit different, I really meant it. On this channel, I don't script anything. However, I do usually have a pretty good idea of what I want to say every time I hit the record button on the camera. And if it goes in completely the wrong direction and I talk myself into a corner, I hit the stop button and I hit record again, and I just go again until it sounds right. I have no idea how to use this machine. Let me give you a little bit of background in case you're not familiar with the stuff that I do work with. I have a 7x28 manual milling machine. I have a 14x40 manual lathe, and I have a 10x22 manual lathe. And I would consider myself to be a proficient hobbyist in manual machining, both on the lathe and the mill. And I would consider my skill level on 3D printing to be probably advanced. I wouldn't go as far as to say expert, but I've been printing nearly every day since 2018, starting with a ANET A8 that I built from scratch and did a whole bunch of modifications all the way up to a current generation flagship H2D from Bamboo Lab. But I don't know anything about CNC machining. And I'm guessing a lot of people watching this video probably also don't know a lot about CNC machining. Now, all I've done is taken this machine out of the box, plug it in, And everything else they sent me, I put down here in this drawer. I'm not even sure what some of this is. I believe that is a 4th axis. They did send a material sample kit. I actually have a laser module for this too, and a whole bunch of accessories here. And I think there's even more tool bits in one of these other boxes. Yeah, there's a whole bunch more in there. So my guess is that we probably have everything we need to go ahead and try and make this part. I don't think they sent any aluminum stock that big. Yeah, I've got some pieces down here that should be more than big enough for that. We'll probably just have to cut a piece off with a saw. So I'm gonna keep this video as raw, as unedited, and as real-time as possible, because I feel like this is kind of a once-in-a-lifetime opportunity. I think I have the right background to figure out how to use this, yet at the same time, I have no idea how to use it. And again, I think a lot of you are probably in that same boat. So I'm gonna try and capture as much as possible of me going from having just taken this out of the box to hopefully making this part as possible. Now it is 4:30 p.m. on Friday, the day that you're hopefully watching this video. So I don't know how far we're gonna get. Maybe we're not actually gonna make any chips today. I don't know. I haven't even downloaded the software for this. Speaking of, that's probably a good place to start. Let's go do that. Okay, so I just typed in Makera.com, software, and we have Makera Cam and controller. I think this software is what actually runs the machine, and I think this is what we use to create the toolpath. So let me download this and install it. All right, I downloaded the Makera Cam software, and opening it up, it's asking us 3-axis or 4-axis. I don't think we need 4-axis for this. I would think 3-axis should be enough. See, trial period remaining 16 days. Looks like I probably have to register something. Stock. Yeah, I don't know. We're not that far yet. How do we get the STL into here? File, import 3D model. Okay, that's promising. Not sure how to interact with it. Kind of drag it around. All right, guys, I've been clicking around in here for a few minutes, and the more I know, the more I realize that there is more that I don't know. So I think the learning curve here is a little bit too steep to try and just figure this out. I think I'm actually going to come up here to learning and spend a little bit of time in the wiki, taking a look at some sample projects, and I'll bring you guys back. All right, guys, I am back, and I think I need to admit that it was probably a little bit ambitious to think that we were going to machine this whole part here, having no idea how to use the machine or any of the software. You know, you don't know what you don't know until you realize you don't know it. So I spent about 40 minutes watching the tutorials over on the Makera YouTube site, and the best way to get to those, by the way, is to come up to help and go to learning. Don't click video tutorials, because that's just going to take you to their YouTube channel, and it's honestly kind of overwhelming. There's so many videos up there, and it's not clear which ones you want to watch to learn a specific skill. Go to their wiki instead, and then once you're over here in the wiki, there is a Makera Cam tutorials link on the side, and this breaks it out into all the different things that you would want to learn, and you can just click on the video from here. It's much easier to navigate this way. I watched 4 or 5 of these. I know enough to be dangerous now. So back to Makera Cam. One of the things that I have learned is you can work with STLs in Makera Cam, but you're much better off working with a step file. Now, I'm kind of artificially limiting us to an STL here because, well, first of all, I only have this in STL format. But second of all, I think a lot of people that pick up one of these machines that don't have a lot of experience, they're just, coming from the 3D printing world and wanting to be able to make things out of wood or metal or other materials as well, are going to have this idea that you can pull an STL in here and make that. And you absolutely can, But when you pull in an STL as a 3D object, you can't work with all of the contours on the model like you can if it was a step file. And that does make a difference. Now, we can cheat and get some contours out of this, but not all the ones that we need. For example, we can get the contour of this hex, we can get the contour of this bore here, and we can get the contour of the outside. We can't get the contour of, say, like this chamfer or this round over here. We could kind of infer them or make them up, but we can't just work directly from this and get a whole three-dimensional part. What I think is probably a good goal for this video is to cut the contours of this in a piece of material. And you notice I changed the stock size here. The hunk of aluminum that they included with the machine is 101 millimeters square by 5 millimeters in the Z, in depth. I think that's going to be a good test piece to start with, and just cut the overall contours here to kind of get a handle on, you know, basic tool paths and how this machine works before we dive into something more advanced like trying to machine this whole thing. So if I click this object, I can right click it and hit trace, and I can get a 3D contour. Now I'm going to change the angle here a little bit. So that 3D contour, actually let's just turn the model off because I want to make sure I'm selecting this contour now. And we're going to do this in a couple different operations is my thought, because we have this hex. That's the tricky part. This is a circle. This is a, you know, a straight and circular path. We could cut this with almost any size end mill and be fine. The hex is a bit tricky because we need to get into these tight corners. Now, we're not going to be able to make the corners not square, but as sharp as they're depicted here in the drawing. That's just not going to happen. There's not magically an end mill. Think about it. An end mill has to be round. So as we come into this surface, it's got to get to the point where the front face of the end mill is touching this, and then we got to change directions and go here. We're never going to get all the way into that corner. Now, the smaller diameter end mill you go with, the tighter you can get into corners. And this isn't unique to this machine. This is just, you know, milling basics. You can only make a corner as tight as the diameter of your end mill. So what I'm thinking is we can use a larger end mill for cutting out the overall shape, and then for cutting out this round bore, and I guess roughing this hex, but we're going to need a smaller diameter to actually get the hex as tight as we can. So I also took a look through the tool bits that they gave me with the machine, so I have an idea what ones we can actually select. So let's take this path. Let's make a tool path from this. So if we go 2D path, I believe we want contour. Now, position is important because you have to think about what are you trying to get. Are we trying to cut this shape out of a big square and then use this shape inside that square? Or are we trying to cut this shape out of a piece of stock and use this piece? Like this is the piece we keep. So from the perspective of the end mill, we want the end mill. So in this little sort of drawing here, like the blue, imagine is the actual path of the tool. The gray is the diameter of the tool, and this is the stock piece that you're going to have left. So you can see if we choose this one, we end up with sort of keeping this inside piece. If we run the inside path instead, then we cut out more than this shape from the outside shape so that we're left with exactly this path in the overall piece of material that we cut it out from. So we want outside. I think we need to set our depth in here too. Yeah, so start depth 0. The stock is 5 millimeters thick. We want to make sure we get all the way through, so I'm going to make it 5.125. We'll put like a piece of plywood or something underneath of it. I'm not going to touch any of these things, and the default tool in here is one of the ones that we have. We'll leave that. This is, I think, the largest end mill they supply from a diameter perspective. Tabs, we are going to want tabs. We don't want to cut this. If we cut the whole thing out as the, first of all, as we get around to maybe 3/4 of the way around, there's hardly going to be anything holding this in place, and it's going to flex, and we're not going to get a clean cut. So we need to leave some material, say, in the two ends. So I'm going to go to custom, rectangle. Probably don't need 10 millimeters wide. That seems big. Let's go, I don't know, maybe 7 sounds like a lucky number. And we'll make them 2 millimeters thick is probably plenty. And I think we just click on the path. Try putting one at each end here. didn't do anything. Oh, there we go. Guess I didn't really click. Okay. That looks right. So again, I'm not going to change anything else in here. It's pre-filled these values for, well, you know what? It probably doesn't know what material we're going to cut in. Let's see, single flute metal, 3.175. Looks like aluminum's selected by default. Yeah, I don't think anything changed. Let's hit calculate. Okay, that looks right. So if you, I think the white represents the path of the tool, which looks right to me because it's outside of our, the actual cut that we want to make, because this is the center of the tool path. So the diameter of the tool is going to come over here and hopefully hit right on that surface, I think. All right, for these two inner ones, let me close this one. Let's click. If you just click, it's going to select whatever you clicked on. But if you hold down Shift, you can select multiple ones. So I'm going to select multiple ones. I'm going to go tool path, 2D path, 2D. I think we want pocket. Contour is just going to make the one tool path. We want to like mill out all of this material in here. I believe that is pocket. So tool path, 2D pocket. We need to set our depth again. Go 5.125. I'm not going to mess with these. I'm going to be blissfully ignorant of whatever safe position means because I'm not sure. I don't think that was covered in any of the videos I watched. Again, we're going to assume, well, let's not assume. Let's go in here and take a look at this tool. Single flute metal. Okay, no, now we got two in there. Let's delete this one. We also want a smaller diameter one. I think the smallest diameter one is 2x8 that they supplied with the machine. 8 millimeters should be long enough to make that cut at 5.125, but we'll get tighter into the corner with a 2 millimeter versus at 3.175. Select aluminum. So it should make tool paths now for both of these tools, I think. We don't need any tabs. We don't even have the option for tabs on a pocket. I think that's it. Let's hit calculate. Okay. I think that looks right. I can see that must be where the tabs are going to be. I think we can actually preview these tool paths. Let me save this quick. Okay, if we go to path, preview all paths. Okay. All right, that looks like our stock. How do we make this go? Oh, okay. I think this is speed. Yeah, this is speed. If I go back to the beginning. There we go. Okay. That looks like what I would expect. So it's going to cut the outside first. Okay, now that does not look very tight. Is it coming back? And looks like it's still doing this one. I want to see, what I'm assuming is it's going to have a switch the tool and it's going to tighten up these corners. That's what I'm looking for. All right, I've been poking around in here for a little while. I think this might actually be an issue with the preview just not showing us the right tool path, because I've tried all different combinations here and I cannot get it to show me coming back in and using that second tool. But what I did notice is, let's see if I slow this down and we come back out here a little bit, display tool, watch, see it goes back over there and then it just sort of bobs around in the middle. And I wonder if maybe the preview itself is broken, because there'd be no reason for that to come back over. Like it starts here, roughs that out, speed it up, goes over to this one. I'm going to slow it down because as it gets close to the bottom of this one, all of a sudden it flips back here, and it's just, it looks like it's just moving around in the center of the part, like where there's nothing to cut. So I wonder if that's just like an error here in the preview for this. Let's cross our fingers and hope so. I mean, otherwise we'll just end up with these corners not as tight as we'd like with the second tool. All right, I cut us a piece of plywood to fit underneath the aluminum because I want to cut all the way through the aluminum and I don't want to cut into whatever this is. Looking at this, I wonder, I think this comes off. I wonder if we could make one of these, if we could just 3D print one of these and then not worry about cutting into it and just swap it out. I mean, I can definitely print that large on several of my machines. Let's figure out how we're going to clamp this down. All right, I feel like that's in there pretty tight. I don't like that we're not holding it in this direction, but we're probably not going to have that much tool pressure here. So let me get the software installed on my little laptop over here to run this. All right, around the back of the machine, there are 2 ports. I'm assuming that we want to be in data. I would think charging is for, like, maybe if there's a tablet attached to this. The cable that they provide with the machine is not this one. It's like only 3 or 4 feet long, which I guess if you're going to put your laptop like right next to the machine, that's fine. I went and found this. I think this is about 10 feet long. So this should reach over to my laptop. All right, plugged it in, software is loaded, machine is not turned on yet, which is probably why it says disconnected. So let's go turn it on. Okay, some lights are coming on. And I think that's it. Doesn't appear to be doing anything else. Let's go back to the software. Okay, this is still showing disconnected. USB. COM3. Ah, connected to machine. Okay. Looks like it maybe downloaded a config from the machine. All right, we're definitely connected now. How do I know? Well, we go over here. We can actually manually jog this guy around. So that looks like it is working. And we can home it as well. So I think it's time to get some tools in here. I went through all the tools they provided. That's how I figured out which ones we could use. These are all not ones for metal. These ones are for metal. And these are the 2 that we're going to use. We got the 3.175 by 12 and the 2 by 8. So I think we need to install collars on these. There's a bag of collars in here, and I noticed this guy has a collar on it, and I believe this is an installation tool for that. Let me take a look in the quick start guide and see how you do this. All right, so they show this tool being used in 2 different combinations here, depending on whether you're trying to install the collar or remove the collar. So I'm guessing this comes apart. Okay, looks like we don't use this one for installing, but there's 2. Oh, is this 2 pieces in here? So we're going to need 2 of these, 1 for each of our end mills. A cute little end mill. And they show it like this. That seems really loose in there. But that's how they show it being used, unless there's a, like, is there a different spacer? No, I don't see any other collars. So let's try this. Maybe it's supposed to be loose in there. What I'm talking about is this part here. Like, I would think that that would fit in that spacer tighter. So this collar goes over like that. And then this goes over that. And I think we screw this in. I'm also not able to bottom this out all the way, but maybe I'm not supposed to. Let's see what we ended up with. Okay, so I think what's limiting the depth is this right here. So it does look like we are at the depth that they want. But you can see by the inside face here that we weren't, like it wasn't turning it on straight. I think I might make another one of these adapters for the 1/8 inch end mills on the lathe that is the right size for 1/8. I don't know why they're slopping that. It seems like of course we're going to end up with it sort of driving it a little bit crooked like that. All right, so we'll do the same thing for the other one. Screw this front on first. It's still going crooked in there. I think we need to make another piece. I'm not going to worry about it today, but I want to make a proper sleeve for these 1/8 inch bits in the lathe. I don't know why there would be slack in there. See if we're at least consistent between these two. Yeah, so those are driven onto the same depth. So I guess that's right. I think it might be nice to design like a little 3D printed tray for these to sit in as well, maybe with some tool numbers on them, because if I recall, I think we made this one tool 4 and this one tool 1. Probably be nice to have something set up to drop them into so we know which ones are which, because we are the tool changer on this machine. So back on the laptop, we've got to get our file, our G-code to the machine. Open the G-code. Okay, I put one in the temp folder on this machine. I think this is showing us what's on the machine. We want to do upload file. Okay, so upload and select. I think that's uploading it to the machine. Okay, we can actually see the toolpath there, I think. All right, I moved the emergency stop button over to this side of the machine because I'm not entirely sure what is going to happen when we hit start running G-code task. I hit go and it is saying please change to tool probe. So let me get you guys in the tripod here. The probe is this little guy here on the side. And we are the tool changer on this machine. It's pretty easy though. There is this arm you pull down. That opens up the collet. This guy's going to go in, and then just by letting this back up, it tightens up that collet. So it's kind of like a quick change collet system, I guess. Now I'm going to hit confirm. I think it's going to come down and touch that pad so it knows what the Z height of the spindle is. And I think that is the start of the actual cut that it's probing. Okay, it's beeping at us again. Please change to tool 4. Okay, this is tool 4. Confirm. Okay, now I think it is going to probe the tip of that tool to see where the actual end of the tool is. Is it just going to start cutting? Should we close this lid? Yeah. boy. Hovering on the stop button here. Okay, I think that's okay. We might be a little close to that clamp. Yeah, I think we're going to be okay. Sounded a little aggressive there as it moved down. That's probably what that ramp function was that maybe we should have used. I'm sure you guys that are actually familiar with using CNC machines are probably roasting me down in the comments. That's fine. This is how we learn. You know, hindsight being 2020, we probably should have done the pockets first, because now we're going to only end up with those little tabs holding this in when we cut the pockets. Making a big mess in there. We've given it no way to evacuate those chips. I think the next thing I'm going to do is probably figure out a way to print a adapter for the back to get the shop vac attached to this. We can actually see a live preview of the toolpath on here. It kind of stalls in the long straight sections, probably because we only get an update when it's actually running the next part of the G code. Like that's just one long move there in that straight section. That's why it kind of just hovers in the center. But we can see we're down to a depth of 3.35. Again, hindsight being 2020, I really wish I'd done the pockets first. We're only going to have those tabs to hold this part now for the next operation. But, I mean, that's the type of silly mistake that somebody new to this is going to make. So, get you back in the tripod. Okay, I see what's happening. It's cutting those tabs now. That's why we're hearing that sort of crunch sound at the ends. I think we can actually see it lift up here. Yeah, you can see it lift up in the Z and skip over where that tab is. So, we're getting close. All right, I can see all the way down to the wood, except for where those tabs are. We've got quite the mess in here. I'm sure we're not going to have the best surface finish because we did nothing to evacuate the chips. So what happens is when you're milling, if you don't evacuate the chips, you don't clear the chips in some fashion, the chips essentially recut the surface. They get pulled back in by the end mill and they just smush against the surface and you get a terrible surface finish. So that's probably what happened here. But again, first time. Let's get this vacuumed out and cross our fingers that those little tiny tabs in there are going to be enough to hold this part in to do those pockets. All right, there's no point getting it any cleaner than that because we're just going to make a mess in here again. I gotta say, from here, it actually doesn't look like the surface finish there is too bad on that contour. But let me load up the G code and let's try the pockets. All right, running into an issue. So that all finished perfectly, no errors. But when I'm going to load the next file, so our inside pockets, when I selected the outside contour before I hit upload and select, I'm doing the same thing here. And it's saying upload file error. Let me try just uploading it without upload and select. No, that's not working either. And so this is showing remote side. Here's that one that's loaded. There's examples in here. Actually, no, it won't load that either. It's like it's lost communication with the machine. I'm not sure what to do because if I turn the machine off and turn it back on, which would be the normal techie thing to do as a first step, aren't we going to lose our position? And if we do, then we're not going to cut the pockets in the right place. It shows that it's connected. I guess we could try disconnecting it from here as a first step. Okay. Okay, it connects. Download config file error. It's like it can't talk to the internal storage. That's what it's acting like. I bet you I have manual control over the machine itself. Let's see. Yeah. So we're talking to the machine. It's like the storage on board the machine failed. I don't know if there's an SD card in there somewhere or what. I don't know what to do here, guys. I guess we can try power cycling the machine. But again, how are we going to get back to our 0 position? All right, guys, I don't see any other option. I think we're going to turn this off and turn it back on again. I mean, I'm assuming there's an SD card here somewhere, but it's not accessible like on the back of the machine. It's probably inside. So, all right, here we go. All right, it's still showing connected in here. It says idle. Let's try it again. Okay, that's not a good sign. I think it's trying to display the files that are on the SD card in the machine. Yeah, it's acting like it just cannot read the storage in the machine. Let's try it again anyway. Upload file, inside pockets, upload. Now, are we still actually connected since we power cycled it? Yeah. I mean, the machine itself is fine. It just cannot read its own storage. And I guess the only other thing that we could try is just closing the software and relaunching it. Okay, so now we're not even connected. COM3, reconnect to machine. Download SD config info canceled by remote. That doesn't sound good. Oh, okay, wait a minute. That's showing us, I think, what's in there now. Inside pockets. Hey, there we go. Okay, so it might have been on the software side on this end. Now, I don't know that we are in the right position is the problem. Now, I guess let's try homing this since I did just move it around, because I think it ended the last operation homed. Oh, go to work origin. Let's see what happens. That actually might be the work origin. We might be okay. Let me get you guys back on the tripod. Okay, it's asking for the probe. That's a good sign. It's asking us for tool 4. That is the big guy. And I think it's just going to start. Let me get this closed. saying we have 1 hour, 16 minutes left to go. I hope that's not accurate. It doesn't seem like it would take that long to pocket out these 2 holes. So take a look at this. The software has miraculously jumped ahead. It's now saying 10 minutes elapsed, which is probably right. I think 10 minutes has elapsed, and it's saying 6 minutes, 5 seconds to go. So that's much more believable. And we're still getting a nice preview here of the G-code and the actual tool paths on the screen. All right, so that is the end of the tool path for that larger tool. Now here's where I'm not really sure what is going to happen, because the preview of this next tool path definitely didn't show us anything useful happening. But I think it's asking for the next tool. Yeah, please change to tool 1. So let's do that. This guy's probably hot. I don't actually see a chip on the end. Got it, yeah, okay. I mean, the tool still looks perfect. Okay, so here is our small end mill. I imagine it's going to probe this guy. I'm going to close this because I know it's going to probe it and then it's just going to start cutting again. You know, I'm not going to vacuum that out. Let's just see what happens. Actually, no, I lied. I'm going to, because if I don't vacuum it out, we're not actually going to see if it's doing any cutting. Okay, moment of truth. Guess I should get my finger back on the emergency stop button here. Yeah, and that's not doing what it's supposed to. So it looks like the CAM software did not correctly give us a tool path for that tool, which is unfortunate. It's doing exactly what the preview showed. It's just kind of going around in a circle there in the middle. All right, well, I guess that is as done as it's going to get. I'm not sure what to do about that other tool path. I mean, I guess I could run up to the Makera CAM software and delete the larger tool and create a tool path with just that smaller tool. It doesn't hurt to try. Be right back. Okay, so unfortunately, we're back to the same error that we had before here. I mean, this looks like this must be a bug in the controller software on Windows. It's doing the exact same thing that it did before. So I'm going to assume I can fix it by closing the software completely out again and relaunching the software. Okay, COM3. And upload file. So inside pockets, take 2, upload and select. Yeah, again, that worked. So I don't know what's causing that issue, but it looks like this worked. Now, unfortunately, I think it's probably going to have us now go and probe this all over again, but let's do it. Oh yeah, that's going to be a problem. That's not the correct Z, because that's already been machined out. So I don't think we're going to be able to correct that. I would have to put a piece of aluminum in there, and we actually machined down a little bit below the bottom face of this. So I don't know how we set our Z height. All right, 2 of these magnets is actually about 5 millimeters in height. So if I set those guys in there, assuming our probe is not magnetic, which it might be, I guess I could put a piece of tape over that. All right, this is so ghetto at this point, but I really want to see it run this other toolpath with the smaller tool. So I think what I have to do now is halt it and reload the G-code because I want it to probe that again. Okay, so the problem I have now is all I can do is tell it confirm. I guess we're going to have to confirm and then stop it because that is not tool 1. Okay, so I think if we just start this again, it's asking for the probe, good. Let's see if we have successfully fooled it. You know, I guess those magnets could also potentially impact how the probe works. That was the only thing I had that was like easy to grab though, that was going to give us the right thickness. Okay. Get you guys back in the tripod. All right, it's asking us for tool 1, so we'll take out our magnets. Here is our tool 1. I don't think it's at the right location. Actually, no, I know what's going on. It's running the whole toolpath again. Because to get it to give me the correct toolpath for this tool, it thinks it's doing the whole cut all over again with this end mill. But that's okay. I think it's still actually going to, yeah. It is going to make the cut. You know, I just noticed there is actually an option here in the software for speeding this up. We could speed this up. It's only ever going to be cutting like just in the corners, and the chip load is going to be super small because it's only taking out the material that the other end mill missed. I'm tempted to speed this up and see what happens. So scale 100%. Should we live dangerously? %. I can hear it going faster. It just made a cut. It's doing the outside. I think we're going with this. Let's go further. 160%. 170%. Why not? How far does it let us go? We get all the way to 200%. 190. All right, 200%. So the CAM software definitely knows how to create the correct toolpath for this tool. There just seems to have been some bug in it creating the toolpath to clean up from the initial tool. I definitely had them in the right order. The software tells you that you're supposed to have the largest tool on the list first. And I actually noticed when I had the smaller tool selected that we don't have, the end mill that's even a smaller diameter than this one, it did do the toolpath correctly. So maybe it's an issue with the way that this tool is configured in their library, or maybe it's a bug in the CAM software when the difference in diameter is below a certain amount. I don't know, but it's working. Wow, that actually looks really clean. Let me see if I can break it out of here. All right, I probably removed those tabs in the least best possible way. You can see I actually chewed into the surface there a little bit. I just used a handheld reciprocating saw. It was the closest thing to grab, and this is just a test. I did smooth it over with the belt sander there. And then I just kind of touched all the edges on the belt sander and deburred these inside surfaces as well. But I mean, this looks fantastic. Like, I'm genuinely surprised how nicely this came out. I think our finish down here, let's see, would that be the, yeah, I think that would be the bottom. If you notice the decrease in quality on the surface finish, I think that's recutting chips, just because we were doing nothing to clear the chips. It looks a little better on this side. Doesn't seem to have mattered so much on the inside, probably because we ran that second tool path and there really wasn't much chips in there. Although we did nothing to clear the chips in this side, and that also looks fantastic. I wonder if this fits on the vise. Yeah, fits perfect. There isn't much room in those corners. I think if we did not run that second tool path with the 2mm end mill, I don't think this would have fit on here. I mean, we probably could have just touched all those with a file, but it fits perfect. I cannot get over how nice this came out. All right, so keep in mind, this is my opinion after doing a single project with this machine. But it's not what I expected. I kind of thought they would have the software really polished and the machine would be built like just good enough to get something done. Yeah, this machine's actually built pretty nice. It doesn't show well in pictures and video. At least the reviews that I had seen, my initial impression was, yeah, it looks like it's really built to a price point. I don't feel that way seeing it in person. Like, it's tough to get a sense of scale. You see that in my hand. Look at this up against these rails in the back of this machine. Like, they're huge. Like, everything on this machine is bigger and built more sturdy than I expected it to be. And that's a good thing. And we've got linear rails back here for the Z-axis. The quick change collet for the tools does work well. Would an automatic tool changer be better? Yeah, sure, but I mean, they're clearly saving cost in not putting it there, and it's not difficult at all to use. I'm genuinely impressed. Where I'm let down is by the software. You guys saw the issues that we had with uploading files, and that's not the only problem I had. When I was not recording, the Makera Cam software crashed on me, actually twice. So I think that's where there's room for improvement here, is the software. Now, you don't have to use their cam software to do your tool paths. I think you might need to use their controller software to run the machine, although I'm not 100% sure on that. We could certainly make the tool paths in Fusion 360 or Onshape or another CAD program that does cam. But yeah, I think that's where there's room for improvement here. And let's also not forget that it did not correctly form the tool path for that second tool. I don't know if that's an issue with their configuration of the tool or what, but I mean, I double, triple checked my work. I'm 99.9% sure I had the tool selected and configured correctly in that 3D pocket. So let me know down in the comments if you saw me make a mistake there, but I really think the CAM software itself just didn't correctly formulate that tool path for the second tool. So you're definitely going to be seeing more of this on the channel. It is a lot bigger and a lot better built than I expected. So I think it's earned a permanent spot on the workbench. And I really like the idea of being able to produce parts for our projects in metal when that makes sense. I've heard that this machine can do steel. It's just not really well suited to do it. But I mean, even being able to make parts in aluminum, like there's no material I could 3D print this out of that would just be as strong as this is in aluminum. So that's already a step up for components on things that we design that are just not really a great fit for 3D printing. So let me know down in the comments. Did you find this video interesting? Again, you know, I warned you guys at the beginning this was going to be a very different video. It was watching me on purpose kind of, you know, bumble through trying to figure this out, because that's what anybody is going to be doing that picks up one of these machines that does not have experience in CNC machining. If this is your first time here on the channel, we normally do functional 3D printing, although we have done some machining in the past as well on the manual side, you know, on my manual milling machine and my 2 lathes, you know, when it's the right fit for a specific component in a project. But it's mostly 3D printing and the functional side of 3D printing and the engineering that goes along with that. So if you're into that sort of thing, check out some of the other videos on the channel. And if you like what you see, hit the subscribe button. And guys, if you do, I'll see you next Friday.